Today we will be starting with chapter 4 of your maths, that is linear inequation. Alright, so you have learned about linear equations. Linear means power 1 and equation means like basically equal to, right? So what is inequation? Let's try to understand the difference between linear equations and inequation with a simple example. So if I ask Abigail, how old are you? So let's say your age is X. So what will be the value of X? X will be 15, right? Or 16, depending upon your age, right? But what is inequation? Now here the question can be like, let's say Ananya, let's say you have just given an exam and I ask you, how much marks do you expect? So what do you say? How do you say? Tanisha, you're nodding your head.
Who's 80 above, 90 above?
Yes, that's how we answer, right? We say 80 plus, at least we'll get 80 plus or 90 plus if you are very good, 95 plus, yes or no? But you cannot pinpoint that I'll get 90 or I'll get 80, yes or no? So, when we say how much marks do you expect, then let your marks be X, then let's say you say above 80, right? That means now X will not have one value, it can have multiple values. It can have values like 81, 82, 83, 84 all the way to 100, right? So there we cannot use equation to represent this scenario. We have to use an inequation. If you see the way we have written the inequation, X is greater than 80 because you said you're expecting more than 80 means 81 or so, but it should be less than 100, right? So in inequation you get a range of values, whereas in equation you get one particular value. Is that clear? Alright. Now the way we simplify a linear inequation is very different from the way we simplify linear equation. Alright. So there are certain scenarios where we have to change the inequality sign. Alright. The way they change is, for example, greater than might change to less than, greater than equal to might change to less than equal to, less than might change to greater than, and less than equal to might change to greater than equal to. Basically, we flip, we reverse the sign only under certain circumstances. Right? Let's try to understand those circumstances. But before that, let's try to understand when does it not change. So there are two situations when it does not change. For example, adding or subtracting on both sides, or the way we usually learn, transferring plus or minus numbers between the inequality. Let me give an example. So for one, let's take an example. Let's say that I write 2 plus 5 is greater than 6. Do you agree?
Yes.
Yes, 2 plus 5 is 7, which is definitely greater than 6. Now, if I transfer plus 5 to this side, then what do I get? Yes, 2 is greater than 6 minus 5, which is 6 minus 5 is 1. Does this still hold? Is this still true? Yes. So that means even if we don't change the inequality, it's correct. Okay? Okay. Number 2, when we multiply or divide on both sides, or the way we learn it, cross multiplication of coefficients, but the coefficient has to be positive. Alright, keep this in mind. Only when the coefficient is positive, the sign does not change. Again, let me explain with an example. So for 2, the example will be, let's say 2 into 4 is less than equal to, let's say, 12. Do you agree? Yes, 2 into 4 is 8, which is less than equal to 12. Let's say I transfer this coefficient of 4 to the other side. So we know that multiplication becomes division. So it will be 4 is less than equal to 12 upon 2, which is 6. So 4 is less than equal to 6. Do you agree? Yes. So this is still true. So we do not change the sign. Okay. Now these examples will be more relatable when you see then when do we change the sign? Let's see. So when do we need to change the sign? So the inequality gets reversed when, number one, multiplying or dividing both sides by a negative number. Alright, when we do this step, but with a negative number. Let's try to understand this. So number 3's example. Let's say we have minus 2 into 3 is less than 4. So do you agree? Minus 2 into 3 is? Minus 2 into 3 is? 6 minus 6, and this is 4. So minus 6 is less than 4. But see, if I don't change the inequality and if I just transfer this minus 2 on that side, then what do I get? 3, let's say, less than 4 by minus 2. Then if I cancel this, I get 2. So I get 3 is less than minus 2. Is this true? No. This is what? This is false, right? Yes or no? This is not correct. That means, should we not change the reversibility? Should we not change the inequality? So we should have changed it to greater than. Now does it hold or not? Is 3 not greater than minus 2? Yes. So in this situation also we have to change. Then when is the other situation where we need to change? The other situation is when we take reciprocal. Now this might be a little complicated for some of you, but just focus. Number 4 example will be, let's say, let's say 2 is less than 3. Agreed? We all know that 2 is less than 3. But what if we take reciprocal on this side? So reciprocal means 1 by 2. And what will be the reciprocal of this? 1 by 3. So if I don't change the inequality, it will look like half is less than 1/3. Now, is that true? No. Half means 1 piece into 2 parts, and 1/3 means 1 piece into 3 parts. So obviously this has to be smaller. So in this case also we have to change the inequality sign. Alright. So basically number 4 and number 3 you have to remember, because students make mistake here only. Alright. Okay. So now let's see the next part. So now we're going to learn about set. Okay. It's a very important definition for the first exercise. So what is set? You don't need to write the definition. A set in mathematics is basically a collection of well-defined items, okay, known as elements. Alright. For example, let's say a set of Barbies, right? So we know which objects are Barbie. So when you collect many Barbies, that becomes a set. Alright. Or let's say a set of bicycles, right? We have many bicycles here. So when you collect them all, that becomes a set. And each Barbie here or each bicycle in this set are called elements. Alright. Then there are 2 types of set. The first one is replacement set. Again, these are very important for your numericals. So what is replacement set? Replacement is basically the set from which the values of the variable are chosen. Like for example, let's say your marks. Okay, your marks, can it be any value? No, it has to be from 0 to 100. Yes or no? Worst case 0, best case 100. It has to be between them. So 0 to 100 becomes your replacement set. Means only those values are possible, no matter what the equation. Okay. And then we have solution set. So what is solution set? These are basically the values from the replacement set. Means we have to take values from the replacement set that satisfies an equation. For example, let's say that the replacement set is 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, 1 to 9. And let's say the equation is such that x is greater than 3 but less than equal to 8. So what will be the solution set? it'll be only those values from the replacement set that satisfies this equation. So the only values that satisfies are what? 4, 5, 6, 7 and 8. 9 does not satisfy, 1, 2 and 3 also does not satisfy. So that will be your solution set. Is that clear? Alright. Sets are always written between the curly braces and the elements are written inside separated by a comma. You got it? Okay. Then let's see some common replacement sets in maths. So the first one are natural numbers. So what are natural numbers? Natural numbers are all the numbers from 1 to infinity, right? Basically the numbers that we use for counting. Like if I want to ask you how many students are there, so I'll go 1, 2, 3, 4, 5. That's how we start and we can go all the way to infinity. Okay. So that is the first set of natural numbers which is from 1 to infinity. And here if let's say the variable is x, we say x, this symbol is belongs to. X belongs to natural number. Okay. Okay. After natural number, what do we have? Whole number. The next set is whole number. So in the set of natural numbers, if you add the number 0, then we get whole numbers. So whole numbers are basically 0, 1, 2, 3, 4 all the way to infinity. After that, real numbers. Not yet. Integers. Before that we have real numbers. So in the whole number set, if you add all the negative numbers, right, you will get integers. So it will be from minus infinity to infinity. Now the only number left are what? The decimals or the fractions. Now in if you add decimals or fraction to integer, then you get real numbers. This is basically all the numbers that you will see in your book. Alright, so natural number 1, 2, 3, 4, 5, 6, 7. Whole numbers 0, 1, 2, 3, 4, 5, 6, 7. Integers minus infinity, minus 7, minus 6, minus 4, minus 3, then all the way to infinity. So decimals are not there. Real numbers from minus infinity, let's say 0.0 to plus infinity 0.0. Alright, so these are some common set. The symbols are very obvious. For whole number it's W, for real number it's R. The only thing is for integers. For integers, sometimes in the book they write Z or I. Alright, so remember that. Okay, it's just basic. Then how do you represent this solution set? How do you write this solution set? Right? So one way to represent the solution set is, let's take this example. Let minus x be greater than minus 3 and less than equal to 8. And let's say x belongs to whole number. So the first way to represent is known as the rooster form. In rooster form, you literally write down all the possible values, like all the way from minus 3 to 8. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. But x is greater than minus 3. So why don't we have like minus 2, minus 1? Because, very good, because the replacement set is whole number. So is minus 2 and minus 1 whole number? So we can't put it in the solution set. You got it? Everyone? Okay. Then we have in the set builder form. In the set builder form, we will write x is greater than minus 3 and 8 and x belongs to whole number. Okay. Generally, set builder form is preferred for real number when the replacement set is real number. But here I'm just giving you an example. Alright. And the last and most important one is the real number line. So have you seen this real number line in your lower classes? So in real number line, what do? We draw a number line and we write the real numbers, all the numbers, and we will write the values like this: 0, 1, 2, 3, 4, 5, 6, 7, 8. But instead of writing them, we will mark them in the number line. 0, 1, 2, 3, 4, 5, 6, 7, 8. Done. Alright. This is asked almost all the time only in the question, that put it in the real number line. Is it okay? Got it? Okay. So, any questions? we're done with the introduction part. We will do the sums now. So let's see question number 4. 3 minus 2x is greater than equal to x minus 12, and it's given that x belongs to natural numbers. Alright, so how do we solve this? So we will be solving it as an equation only, but just remember, when do we change the inequality? So when do we change the inequality? When we, if you remember the two rules, when do we change? Negative number, or if you take the reciprocal. Alright, so let's see if that step is involved or not. So I'm going to take minus 3 that side. So here I'll have minus 2x, and this here will come minus x, and the sign will remain the same. So this will go here, minus 12 minus 3. Just be careful when you cross multiply or take reciprocal. Okay. So then we have minus 2x minus x will give minus 3x is greater than equal to minus 12 minus 3 will give minus 15. Right? Now here generally what do? We cancel minus both sides, but please don't do shortcut for this chapter. So what should be our next step? We'll take minus 3 to that side. Yes or no? So we are cross multiplying, so we have to be careful. Does my cross multiplication involve a negative number? Yes or no? That means I have to change the sign. So now the sign will change something like this, since we are cross multiplying a negative coefficient. Okay. Then it's normal again. So x is less than equal to minus cancel, 3 5s are 15. So that's your solution. Okay. So what will be the possible values? The solution set? Yes, very good, Ananya. 1, 2, 3, 4, 5. So question number 5. 25 minus 4x is less than equal to 16. So if you take it that side, we get minus 4x is less than equal to minus 9. No cross multiplications, I will not worry. In this step, I am cross multiplying, so I have to be careful. So I will be cross multiplying minus 4, that means the sign will change. So minus 4 by minus 9 by minus 4, minus minus cancel, 4 2s are 8, so 1/4. So this implies x will be greater than 2, 1 and 1 by 4. That's all you got? Yep. Now let's see this part. Okay, it's very interesting, this part. Question number 1. Now it says the smallest value of x when x is a real number. That means the replacement set is real number. So what will be the smallest possible value of x? We know that x must be greater than 2 1/4, means 2 1/4 and greater numbers, right? So what will be the smallest possible value for x? Let me show you with the number line. For example, we have 0 here, and we have 1, 2, and then 3. So 2 1/4 will be somewhere around here. Okay, 2 1/4 will be somewhere around here. Here we are saying x must be greater than 2 1/4. That means all these values are possible values of x. Yes or no? Can we have x on this side? No, because on this side it will be less than. So which is the smallest possible value? 2 1/4. That will be the smallest one, because all these numbers will be greater than 2 1/4. Now what about this then? The smallest value of x, but when x is an integer. So can we take this value now? No, because x has to be an integer. So from these values that are possible values of x, which is the smallest integer that you see? 3. That means for number 2, x will be equal to 3. So what do we have? Question number 7. 5 minus 2x is less than 5 1 by 2 minus 5 by 3x. And x is an integer. So x belongs to integer. You can write z or you can write I. So let's solve this. So we will bring all the x on one side. So we have minus 2x. This, if you bring it this side, you get plus 5 by 3x. Since we're not cross multiplying, the sign will not change. Then we can carry this side. So we have 5 1 by 2 minus 5. Nothing complicated. We're just shifting the numbers this side or that side. Then here we can take LCM. So the LCM will be 3. Then this will be minus 6x plus 5x is less than. Here if you solve this, 2 5s are 10 plus 1 11. So 11 by 2 minus 5. Then minus 6 plus 5x will be minus x upon 3 is less than. Here 2 5s are 10, 11 minus 10, 1 by 2. Now I'm going to cross multiply, so we have to be careful. So we have minus x is less than, since it's a positive number, 3 by 2. So this implies, now I'm going to shift minus this side. So since we're shifting minus, the sign will change. So x will be greater than minus 3 by 2. So x will be greater than minus 1 by 2, 1.5. So just draw a number line, okay, just random one. So let's say we have 0, 1 and this side we have minus 1. Since it's minus 1.5, so it will be till minus 2 and your number minus 1.5 will be here. X is greater than minus 1.5, that means it will be all these possible values. You know. So which is the smallest one that we have? Minus 1, right? So what will be the smallest value of x? Therefore, the smallest value of x equals to minus 1. Let's see a question that can come in the exam, okay? Generally, when questions come from this chapter, it will be of this format. All right, question number 5. So question number 5, you can treat it as very important. So let's see question number 5. We have minus 2 by 3 is less than equal to x plus 1/3 is less than 3 1/3. And x belongs to real number. So the first trick is how to speed up your conversion of mixed fraction to improper fraction. All right. So if you know it, good. But if you don't know, this is how you do it. 3 2s are 6 plus 2, 8. So minus 8 by 3. This is also a mixed fraction, right? Whenever you have a number without denominator plus or minus a number with denominator, it's considered to be a mixed fraction. You can do the same thing here. So 3 into x, 3x plus 1. We cannot add, so 3x plus 1 by 3 is less than 3 3s are plus 1, 10 by 3, right? Now, do you notice what is different in this question from the previous questions? Yes.
So there's 2 inequalities.
Very good. Very good. There are 2 inequalities. So actually this sum you can do a little bit shortcut also, but I'll not go for the shortcut right now. Let me just explain you with the basics. So what do? We are going to split the inequality. From 2 inequalities, we'll make 1 1. Alright, so how do we do that? So for the first inequality, I'm going to take these 2 terms right from the beginning to the beginning of the next inequality. So it will be minus 8 by 3 is less than equal to 3x plus 1 by 3. And then from the end of the next inequality till the end of the inequation, sorry. So it'll become 3x plus 1 by 3 is less than 10 by 3. Okay. All right. Now we know how to solve them individually. So go ahead and solve them. Now what we're going to do, remember we had two inequations in the beginning. Now we have to combine them back. Okay, we cannot leave them as two inequations. We have to make them one. We have to combine them. Now to combine, I often prefer this trick that for the first one, you always keep x on the right hand side. And for the second one, you always keep x on the left hand side. That way you will not make mistake. Okay, so you can note that down. It's just a trick. This one you always keep on the right hand side x, and this one you always keep on the left hand side. Now the merging will be very easy. So just write minus 3, then less than equal to x, then less than 3. Done. Okay, it's easier to merge. Now we will draw a number line. So we have to represent this on a number line. So let's draw a number line. So the values that we will need are from minus 3 to 3. So we'll not take extra numbers. Maybe we'll take from minus 4. So minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. Make sure that there are arrows and the gap are consistent. Everyone's ready? This is very important, okay? Everyone's ready? If you're not, just look at the board for now. So, the possible values of x are from minus 3 to 3. That means what are the possible values of x? Minus 3, minus 2, minus 1, 0, 1, 2, done.
It's not equal to 3.
Okay, I agree that 3 will not be there because it is less than 3. So we cannot include 3. Yes? But look at this line. What does it say? X belongs to real number. Real number means all the numbers, right? So that means minus 3, minus 2.9, minus 2.8, minus 2.7, minus 2.6, those will also be included, right? 0, 0.1, 0.2, 0.3, 0.4, 0.5, those numbers will also be included. Do you agree? So, if I start drawing dots for every number, there will be infinitely many dots, right? So then how do we draw for real number? For real number, this is how we draw. Is minus 3 included? Yes, because it's less than equal to, means it's included. When it's included, you make a circle and fill the circle. Okay, don't do it yet. Then it goes till 3. Is 3 included? Yes or no? No, because it doesn't have equal to. So we will make a circle, but we will not shade it. Okay. Then what do? Then we draw a line and then we shade this entire line. So what does this mean? This means that the values are from minus 3 and minus 3 is included, and all the possible values between all the way to 3, but 3 is not included. You got this? Or if you want, you can also do it this way, but sometimes in the book they ask in this way. So you have to know both. So 0, minus 1, minus 2, minus 3, minus 4, 1, 2, 3, 4. So again, the possible values will be from minus 3 to 3. Is minus 3 included? Yes. So I'll draw a straight line. Is positive 3 included? Yes or no?
Yes, sir.
Is it included? Positive 3? No.
1 or 2.
Yeah, so positive 3 is not included, so we will make a curved line. Okay, indicating that it goes till minus 3 or it goes till 3, but 3 is not there. Then we will draw the line and then we will shade.